Welcome to lecture number 1 on the course Foundation of Astronomy. Myself, CBKS, Assistant Professor in Department of Physics. Amateur. Let me tell you what the word amateur means. An amateur is a French word which means lover of. It is generally considered as a person attached to a particular pursuit, study, or science, without pay or often without formal training, just like us, looking into the stars and gazing at it and trying to understand how it behaves without any prior knowledge. And what is astronomy? Astronomy is a natural science that deals with the study of celestial objects such as stars, planets, comets, nebula, star clusters, and galaxies, and the phenomena that originate outside the Earth's atmosphere, such as cosmic background radiation. Actually, astronomy is concerned with the evolution that happened to the universe, the physics, the chemistry, the meteorology, the motion of celestial objects, as well as the formation of and development of the universe. So, person like us could be called amateur astronomers. We can say what you mean by amateur astronomers we are called backyard astronomers, or we are called stargazers. And this course can be considered as a hobby, where the participants enjoy watching the night sky and day sky too. Even though scientific research is not their main goal, many amateur astronomers make a contribution to astronomy by monitoring variable stars, tracking asteroids, discovering transient objects such as comets, etc. Amateur astronomers often look at sky using nothing other than their eyes. But the common tool for amateur astronomy include a portable telescope, a binocular, etc. Now, while I was planning to give an extra department course, we were thinking what is the title to be given. So when the first syllabus was made, we gave the title Astrophysics. Then I thought we will be moving to some more basic topics, so we gave the title as Foundation of Astronomy. So let me tell you what is the difference between astronomy and astrophysics. In strict definitions in dictionary, astronomy refers to study of object and matter outside Earth's atmosphere, or simply the study of universe, while astrophysics refers to the branch of astronomy dealing with the behavior, physical properties, dynamic process of the celestial objects and phenomena. So, bringing to a basic level, that was the idea behind giving the name, the foundation to astronomy. However, since most of the modern astronomical research deal with subject that is related to physics, modern astronomy can be actually called as astrophysics. Now I want to give you a very important point that astronomy is not astrology. That is completely different from astrology. Astronomy means Jyotishastra. Astrology means Jyotish. The basic difference is that astronomy is science, while astrology is a pseudoscience. We have defined astronomy as a science in the strictest sense of the word, while astrology is a superstitious subject and can be called as pseudoscience. The thing is that everyone loves astronomy, while astrology is not loved by everyone. If a small portion of your time is taken out of your life to explore the universe, it is definitely an investment that brings out enormous returns. What kind of returns? I will tell you. The difference is between just mere existence and what is the difference between a life which is well lived. So let us go through astronomy at a glance in this lecture. Our nearest neighbor in the cosmos are the moon, the sun and the planet. So our preliminary interest will be in studying the apparent motion of these celestial objects. So the first person who can be considered as the starting point is Galileo. We all know Galileo. He is called the father of modern observational astronomy, father of modern physics, father of science, father of modern science, etc. According to Stephen Hawking, Galileo, perhaps more than any other single person, was responsible for the birth of modern science. You will very well remember his famous leaning tower of Pisa experiment, where he found that equation of motion doesn't depend on mass. Then starting from Galileo, there were many ideas being put forward towards the development of astrophysics itself. We can name them as Isaac Newton, Sadi Carnot, James Joule, Hermann Helmholtz, Rudolf Clausius, William Gibbs, Michael Faraday, Maxwell, Boltzmann, Einstein, Planck, Bohr, Pauli, Madame Curie, Rutherford, Fermi, Dirac, Feynman. And then of course the most recent persons like Gell-Mann, Hubble, Chandrasekhar, Stephen Hawking, Kaku. Once the problem of motion of celestial bodies like moon, sun and planets were successfully solved, then right now astronomers are looking to study stars which lie far beyond the solar systems. So let's start with a few vocabulary terms. One is, what is universe? Universe is everything, the entire space and time. That is the universe. A little bit time could be spent on what is time, but we will do it in a later state. Galaxy means it is a massive system of stars. It is inside the universe, that exists inside the universe. While solar system, it is a star and it's surrounded by planet. In galaxy there can be many systems, like solar system there is Alpha Centauri system in this galaxy called Milky Way. And inside this Milky Way we are just a tiny speck, Earth, which is a very relatively small planet orbiting around an ordinary star. Actually this sun itself is orbiting in a supermassive black hole at the center of the Milky Way galaxy. And the Milky Way is a spiral galaxy. It contains around 100 billion stars. Billion means 10 raised to 9. And our sun is just one of these billion stars in the galaxy. And in a universe, this whole universe is actually 13.8 billion years old. So I can have a question right now with whatever we have heard, which is bigger. So definitely C is the answer. Asteroid, solar system, galaxy and then the universe. Knowing much more about stars, then astronomers started thinking about the physical properties of stars. It was soon realized that an application of laws of physics to these distant objects could solve the mystery of their nature. And this gave actually a real branch of science called astrophysics. So let us study a little bit with respect to how we are measuring the distance, because the universe is very big thing, very huge thing. So one of the biggest challenge in astronomy is measuring the distance to stars and galaxies. We use the travel time of light to measure the vast distance of universe. So Earth's circumference, we can say that is big, but when we talk in astrophysics, it's just like if a light travels at the snapping of your finger, then it would have covered the Earth's circumference. If the light travels little more than a second away, then you will reach moon. Then that is 1.25 seconds. The sun distance is just like a quick meal. 8.3 minutes you have to finish the meal. Then that much time is one astronomical unit actually. And the Neptune is a planet which is revolving around sun. It takes around 8.3 hours. It's one night's sleep. And if the light travels at that time, then it would work out on the Neptune's orbit. So you will be able to calculate these things. And Proxima Centauri is our closest star. It is around 4.2 years from here if light travels. It's just like you graduate. And actually the Milky Way is 1 lakh years. That's the diameter of the galaxy, is like age of our species. And the nearest galaxy is Andromeda galaxy. The distance between the galaxies is like the time since our earliest human ancestors walked on Earth. And our whole observable universe is equal to 13.8 billion years. It is equal to 3 times the age of Earth. Yes. So light year, you have to understand that it is a unit for distance, not time. But it is the distance traveled by light in that time. That's much 1 year time. It is actually 9.5 million kilometers. So when you are a amateur astronomer, not only you can read about what is going on, but also you can definitely participate. What I am trying to tell you is, the essence is that the sky is calling you and you have to respond. So let us discuss what we are going to study in the coming classes. We are going to have the foundation of astronomy. The aim is to introduce the students to basics of astronomy, to teach the basic ideas of Earth, Sun, Moon system, observational techniques, solar system, galaxy, stellar evolution, and origin of life. We have divided into 3 modules. One module we will be exploring the sky. Second module we will be talking about stars. And third module we will be talking about our solar system. Shall we go deep into it? So module 1, exploring the sky, astronomy, our position and time, relevance of astronomy, stars, sky, its motion, cycle of sun, astronomical influence on climate of Earth, cycles of moon, changeable moon, lunar eclipse, solar eclipse, predicting eclipses, origin of modern astronomy, roots of astronomy, Copernicus revolution, planetary motion, Galilean contribution, modern astronomy, gravity, laws of motion, Galileo and Newton, orbital motions, tide, and of course we have to talk about Einstein and relativity. And then we'll talk about light and telescopes, like radiation, information from space, how we are obtaining using optical telescopes, special instruments, radio telescopes, astronomy, and from space. Module 2, we will be discussing stars, the atom, starlight, the interaction of light and matter, stellar spectrum, sun, solar atmosphere, nuclear fusion, solar activity, the family of stars, the interstellar medium, the formation of structure of stars, stellar evolution, the depth of star, neutron star, black hole. Then we will be talking about the Milky Way, discovery, structure, spirals, star formation, origin and history, galaxies, the family of galaxies, measuring the properties of galaxies, evolution of galaxies, active galaxy, what is a supermassive black hole, modern cosmology, Big Bang theory, cosmic microwave background radiation. In module 3 we will come to solar system. We will have the origin of solar system, a survey of solar system, planet building, the standards of comparative planetology, airless worlds, moon, Mercury, Venus, Mars, moons of Mars, outer planet like Jupiter and Saturn, Jupiter's moons, Uranus, Neptune and other planets, dark planets, meteorites, asteroids, comets. And then we will talk about life, extraterrestrial definitely, life on other worlds, the nature of life, life in universe, the intelligent life in the universe, etc. we will be talking. And the main reference is the book by Seeds and Bachman. And also you can use Abenker. And there are some additional references also you can refer to. So to conclude, I want to say that the foundation of astronomy is a course which is a course based on scientific method. You have to understand what is science. Science is a way of exploring the physical universe through scientific methods. Then you will ask, what is scientific method? Scientific method is a systematic way. It's a systematic way of testing new ideas. You see, one day you start up, you can have an idea or an observation. Then you give a suggestion or a hypothesis. And from this hypothesis you make a prediction. And this prediction should be put in test. It can be correct or it can be wrong. So whenever it is correct, we did not stop there. We go on making the next prediction and test them again. But if something is not correct, then we have to change the hypothesis. And this flowchart deeply explains what science is, scientific method is. Then you have to understand that how hypothesis becomes a theory and how theory becomes a law. Hypothesis is an idea that can be explain a phenomenon. Theory means a hypothesis which is tested and we have failed to disprove that till date. And physical law is a theory that has been well tested and are of fundamental importance. We say Newton's law, Avogadro hypothesis, and theory. Now, as you have known these things, let me conclude with one more point. A starter in astronomy should know this principle. This is called the cosmological principle. It says that the testable assumption that the same laws of physics apply here also apply everywhere at all times. Never think that there is a special place like Earth in the universe, something works out here, never works otherwise. It is always similar, always testifiable at different places. Implication is that our Earth is not special. On a large scale, the universe is almost similar and matter and energy obey the same physical laws. And remember that scientific theories must be testifiable or falsible, and science doesn't stop anywhere, it progresses. We have existent idea, but we will be having more challenges, and we make more new theories, a special theory of relativity. All theories must ultimately agree with nature. So we will have a group admin, WhatsApp group, quiz, field visit, one semester, and we will have it. program if you want. So the summary of today's class is: astronomy is the study of the universe. We use scientific method and language of mathematics to help us understand our place in the universe. And a quote for you to remember: no non-roof is as beautiful as skies above. It's a quote by myself. And it's my daughter. I have a YouTube channel where I will be posting these things. If you are missing these classes, you can just go to the channel and hear to the classes, and come back next day and we will discuss. So thank you for patiently listening. See you in the next class.